Welcome back to my channel, Hastener, the Maritime Traveler. For more interesting videos, do not forget to subscribe. In today's video, I will talk about exoplanets. It's almost hard to believe that until the early years of the 1990s, astronomers had yet to discover a planet outside the solar system. A surprising factor has started to present itself as we learn more about worlds outside the solar system. The universe is weird. From worlds that rain iron and glass to diamond worlds and planets that have escaped the grip of their parent stars, our burgeoning exoplanet catalog demonstrates that our own solar system is reassuringly boring. WASP-76b, the exoplanet that rains molten iron. Spotted in 2013 and further investigated by the ESPRESSO instrument on the Very Large Telescope in 2020, WASP-76b is a planet that is tidal-locked to its parent star BD plus 01316. This means that one side of the planet permanently faces the star, causing scorchingly hot temperatures of around 4,532 degrees Fahrenheit, 2,500 degrees Celsius, hot enough to vaporize iron. The star-facing side of WASP-76b is roasted by radiation that is thousands of times more intense than that Earth receives from the Sun, while the side that faces away from the F-type star experiences perpetual night. HD 189,733b, showers of molten glass. From space, HD 189,733b may appear to be a beautiful and tranquil world, resembling a giant glassy blue marble. With exoplanets, though, appearances can be deceptive, and this definitely the case for this gas giant planet that completes an orbit of its star in just 2.2 days. In fact, its beautiful blue hue arises from its deadly weather, particularly the molten glass rains that pelt the planet's surface. Yet, this isn't the extent of the planet's almost maniacal weather conditions. The exoplanet, discovered in 2005 by both NASA's Chandra X-ray Observatory and ESA's XMM Newton's X-ray telescopes, also experiences winds of around 5,600 miles, 9,000 kilometers, per hour. Gliese 1132b, the planet that grew a second atmosphere. Gliese 1132b is similar to Earth in a striking number of ways. Its radius is only slightly larger, as is its mass. Even its age, 4.5 billion years old, is similar to that of our planet. But this world does have one striking difference: it orbits much closer to its red dwarf parent star, completing an orbit in just 1.6 Earth days. This proximity results in Gliese 1132b experiencing a much higher surface temperature than our planet at 278 degrees Fahrenheit, 137 degrees Celsius, with the intense radiation stripping the exoplanet's atmosphere. This flexing gives rise to violent volcanic activity and causes gases to rush to the world's surface. These gases are building the world a second atmosphere, according to NASA. Kepler-10b, in a galaxy far, far away. Kepler-10b orbits close to its host star, similar to the Sun, at a distance that is a 20th of the orbit of Mercury. This results in an orbit less than an Earth day and a surface temperature hotter than 2,372 degrees Fahrenheit, 1,300 degrees Celsius. Because Kepler-10b, discovered in 2011 by the Kepler telescope, is tidally locked to its star, it also creates molten droplets of iron and silicates. The planet's surface is likely covered with lava much hotter than that found on Earth. Because the harsh radiation from its host star has stripped away its atmosphere, these droplets on Kepler-10b won't fall on the night side of the planet, are instead blown clear of its surface by stellar winds, giving it a fiery tail. Kepler-10b isn't the only lava world discovered by the Kepler telescope. Upsilon Andromeda b, a world of fire and ice. Upsilon Andromeda b is another exoplanet that is probably tidally locked to its host star, completing an orbit in just under 5 days. What makes this planet, which was previously known as Safar, an extreme world is the radical difference in temperature between its dayside and nightside. Whilst the dayside experiences temperatures as high as 2,912 degrees Fahrenheit, (1600 degrees Celsius), the night side is considerably cooler, reaching temperatures as low as -4 degrees Fahrenheit, -20 degrees Celsius. This means that passing the hemisphere of this world could be considered equivalent to jumping into a volcano. HR 5183b, the Whiplash Planet. In terms of exoplanet discoveries, HR 5183b, a super-Jupiter 3 times the mass of the Solar System's largest planet, is unique, as its orbit is highly eccentric, both literally and figuratively. While most planets trace out a mostly circular orbit, this gas giant traces out an egg-shaped orbit around its parent star HR 5183, according to astronomers at Caltech. Ogle 2016 BLG 1928, going rogue. While it isn't the first rogue planet to be discovered, it is the smallest, with other examples much similar in size to Jupiter. The rogue terrestrial world was spotted in late 2020 using a technique called gravitational microlensing, the deflection and focusing of light from a distant star as an object passes in front of it. The duration of the change in the light profile of these distant sources increases with the mass of the intervening object. The disturbance caused by Ogle 2016 BLG 1928 lasted just 41 minutes, thus telling astronomers that it was the smallest rogue spotted using this method thus far. The TOI 178 system, a system of harmony and chaos. At first glance, the planetary system TOI 178 may look like any other set of worlds. But, a closer and more prolonged observation reveals that at least 5 of this system's 6 worlds are locked in a rhythmic dance with each other. The 5 outer planets exist in an 18:9:6:4:3 resonance. This means the first exoplanet in the chain, the second closest to the star overall, completes 18 orbits as the second in the chain completes 9, the third completes 6, and the fourth completes 4, and the fifth, the sixth planet overall, completes 3 orbits. 55 Cancri E, the universe's most valuable exoplanet. Another star that orbits close to its host stars, taking under 18 hours to complete an orbit. 55 Cancri E is also inhospitably hot, reaching temperatures as high as 4,172 degrees Fahrenheit, 2,300 degrees Celsius. Some astrophysicists suggest that such diamond worlds could form fairly regularly when protoplanetary dust clouds that contained high ratios of carbon collapse to form planets. The idea that 55 Cancri E is made of diamond has been challenged since the exoplanet was first discovered in 2004, moving in and out of favor, proving diamonds may not be forever. Planets, black holes. Extreme exoplanets. The most extreme exoplanets may not form around stars at all, but instead could orbit supermassive black holes. Planets form from the gravitational collapse of overdense areas of protoplanetary clouds of gas of dust and supermassive black holes at the heart of active galactic nuclei, AGN, sit at the center of massive churning disks of such materials. Radiation from the AGN could help provide a constant supply of fresh material for planet formation, with the result of this could be runaway formation, meaning planets could reach sizes much more titanic than regular exoplanets. Planets would be less likely to share other similarities to Earth or Jupiter, meaning whole new classes of astronomical objects beyond gas giants and terrestrial worlds to investigate. With the nearest AGN existing beyond the limits of current exoplanet investigations, the discovery of planets may have to wait. I hope you enjoyed this video. For more information, please do your own research.